Okay, so hopefully you guys gave this a try on your own first, but now let's go ahead and go through the answers. So we can't solve this by factoring. We can't take square root off the bat, so we want to do complete the square. So our first step to complete the square is to move that 4 to the other side. So subtract the 4 from each side. And then I'm going to leave a little bit of room because I know I'm going to be doing that complete the square process. So now to complete the square, we make our box. We know we have an x squared at top. We are trying to figure out what to add to both sides, and that's whatever goes into this blank. We know these other two boxes have to add up to negative 6x, and we know they have to be the same number. So for the same number to add up to negative 6x, we do a negative 3x and a negative 3x. From there, we can figure out the outsides of the box. So x times x equals x squared. X times negative 3 down there. X times negative 3 for this top spot. So now negative 3 times negative 3 gives us a positive 9. So we know in order to complete the square, we have to add 9 to both sides of the equation. Now the whole purpose of that was so we could write this left side in factored form. So we want to factor this, which we've already done with our box over here to the right. So when we factor that, it turns into x minus 3 times x minus 3, which is x minus 3 squared. Now the left side or right side of the equation, negative 4 plus 9 would be 5. So once we get to this point, now we can solve it like a normal square root equation. Take our square root of both sides, x minus 3. Don't forget your plus or minus on the root 5. That is not a perfect square. It can't be simplified. So to finish solving, we just add our 3 on over. And we get x equals plus or minus root 5 plus 3. You may have noticed in the book when they worked out that example, they actually typed it into a calculator. You can absolutely do that for the decimal answer. For now, you're welcome to keep it as an exact as well. So there's that one. Now let's do letter B. Make sure we're on the same page. Same process. So hopefully once you get used to this process, you'll be able to be good to go. So first step, we need to move this 6 to the other side. So now we have x squared minus 12x equals negative 6. We want to use our box to figure out how we can make this a perfect square. And if I'm moving too quick, pause for a second. Go ahead and write down what I have written down and trying to digest it as you go. So remember, you can pause if I'm moving too quick on this video, or you can rewind and watch again. So x squared minus 12x, we're filling out a box. So our x squared goes in our top. We're trying to figure out what goes bottom right, and that's what we'll have in both of these spots. We know that these two numbers have to be the same. That's the whole point of creating a perfect square, and they have to add to negative 12. So the only thing that can add to negative 12 is negative 6x plus negative 6x, which means when we take our factors out, we have x and x, negative 6, negative 6, and when you do negative 6 times negative 6, you get a positive 36 to add to each side. Okay, so from here we can factor this side. It's already done for us in our box, x minus 6 times x minus 6, which to simplify we write as x minus 6 squared. And then on this side, negative 6 plus 36 gives us a 30. So equals 30. Now we just finish our solving, take our square root, get x minus 6 equals plus or minus square root of 30. Do a quick check, and that simplified 2 and 15, 3 and 5. No, it cannot. There are no pairs in there, so we don't have to worry about simplifying. We just have to add that 6 to the other side, and we get plus or minus root 30 plus 6 for your final answer. So for the rest of today, there is a Delta Math up that has solving by factoring and solving by completing the square. It'll separate it out and work through it in small chunks at a time. So check that out. Shoot me an email if you have questions, and you guys will be good to go. Have a good weekend, guys.